Hello viewers, in today's session we are going to discuss another important and conceptual problem from integrals, right? And here we are given this problem in which f of x is a polynomial function such that f of x square minus 1 is equal to x raised to 4 plus 5x square plus 6, and we have to find the definite integral of f of x from 0 to 1, right? And remember here f of x is a polynomial function, and the function f of x square minus 1 is given by this polynomial, that is x raised to 4 plus 5x square plus 6, which is defined for all values of x belonging to the set of real numbers, right? And we have to find the value of this integral, right? So what we have to do in this problem, see here the integrand is the function f of x, but here we are given f of x square minus 1. So what we will do, we'll first find out an expression for f of x. So our objective is to get the value of f of x in terms of x, where we are already given f of x square minus 1 is equal to this expression. So here what we can do, let us try to write this expression in terms of x square minus 1, right? See, we have f of x square minus 1 is equal to x raised to 4 plus 5x square plus 6. So now we can write x square minus 1 whole square as x raised to 4 minus 2x square plus 1, right? So here x raised to 4 minus 2x square plus 1 can be created over here, right? So we can write here x raised to 4, then we can write minus 2x square plus 1, such that this quantity remains the same, right? So here we have x raised to 4, then here we have minus 2x square, but here we have 5x square. So what we have to do, we have to write here 7x square, because 7 minus 2 is 5. So we have to add 7x square, and here we have 6, and we have already 1 here. So we can write here plus 5, so that 5 plus 1 is equal to 6, right? So now this trinomial can be written as x square minus 1 whole square, and here we have 7x square plus 5, right? Now let us try to express this term in terms of x square minus 1. So we can write x square minus 1 whole square, and here we can write 7 times x square minus 1, because we have 7x square, then we have 7 times 1 as minus 7, but here we have 5, right? So to compensate, what we have to do, we have to add plus 12, so that 12 minus 7 is equal to 5. So here we can write 12. So we can now have 7x square, 7 times 1 is minus 7 plus 12, and minus 7 plus 12 is equal to 5. So this term and this term are equivalent. So now we can write x square minus 1 whole square, and here we have 7x square minus 1 plus 12. So the expression for f of x square minus 1 in terms of x square minus 1 is given by this one, right? So here we can see that the input is x square minus 1. So now let us denote this term, that is x square minus 1, as say p, right? So we can now write f of p as p square, because we are taking x square minus 1 as p, and here we have 7 times p plus 12, right? So now here we have f of p is equal to this trinomial in terms of p. So now our aim is to find out the value of this integral, right? So we can now write the integral 0 to 1 f of p and dp as 0 to 1 f of x dx, right? So here we have used the property of dummy variable in definite integrals, because we know this property of definite integrals. If we have the limits from a to b, and here we have say f of x dx, then this integral is equal to a to b f of t dt, right? So we can change the variable, or this variable is known as the dummy variable, right? So this property is very useful while evaluating the definite integrals, right? So 0 to 1 f of p dp can now be written as 0 to 1 f of x dx. So now we can write 0 to 1, and f of x can be written from this expression by replacing p by x. So here we have x square, and then we have 7x plus 12, and this is dx. So now we can easily evaluate this integral, and we can now write the integral of x square as x cube over 3. Then the integral of x is x square over 2, and then we have 12 here, and the integral dx is simply x, and the limits are from 0 to 1. So now substituting the limits and taking the difference, first we'll take x is equal to 1 here. So we have 1 cube over 3. Then we have 7 over 2 times 1 square. And here we have 12 times 1. And then we can take x is equal to 0 here. So this term becomes 0, this term becomes 0, and this term is also equal to 0. So here we have 0 plus 0 plus 0, right? So now we have 1 over 3, then we have 7 over 2, and this is 12. Now we can take the LCM. We can simply add these three numbers. So we have 6 here, and then here we have 2. Then we have 3 times 7, that is 21, and then 12 times 6 is 72, right? And the sum of these three terms is 5 here, then this is 9, right? So this is 95 over 6. So the value of this integral is equal to 95 over 6.